more today. So today is Wednesday, 16, 17, 18, January 18th. Yes. Yeah, you folks don't have to sign it, but you have to sign it. Today's the 17th. So does anybody have any requests of songs that you'd like me to sing on parents' behalf? Rudolph the red-nosed reindeer had a very shiny nose, and if you ever saw it, you would even say it glows. All of the... Oh, sorry, I'm coming up on 15 seconds. No one wants me to sing longer than 15 seconds. So volts. We're talking about volts. We've talked about resistance in ohms. We talked about amps, which is current flow, the amount of electrons going past a point in a certain second. And now specifically we're going to talk about volts. Volts is the pressure. In fact, I think we covered a little bit of this slide already. Yep, we did. I remember that. And I recall having a little story about what about your house? If you ran through your house and turned on all the water faucets and flushed the toilets and turned on the washing machine, and on the outside you turned on all the garden hoses, the pressure in your house would go down. But in the case of electrical power coming into your house, there's so much, the diameter of the electrical pipe coming to your house is so big that you could turn on everything in your house and the voltage would not go down. If you had a voltmeter measuring that pressure, the pressure wouldn't go down. So there is a little bit of, that's one nice thing about electricity, is generally speaking, you make the wires big enough that you can turn everything on and everything still works fine. We also did a few, oh wait, for Brian's benefit, when is the test? The first test in this class is... Oh, the test we took yesterday. Okay, the second test, because Brian needs to take the second. Quiz on Monday. Right, the test you actually have to have the material in your brain. And you have to be semi-conscious when you take the test. So be careful, it's going to be at 1:20. So what happens on Monday next week? We covered this week. The quiz on Monday is, quizzes are every Monday as long as we had some kind of a lecture. Now that I hate to disappoint you, but we're going to end up having some weeks where the lecture at all, and then that following Monday there will be no quiz. So I know you'll be disappointed, but you need to start thinking about that disappointment and get over it. So every Monday we have a quiz on the lecture we did the previous week. And the first test, now can anybody tell Mr. Sandoval what's going to be on the test? What topics are going to be on the test? Uno, dos, and tres. Topics 1, 2, and 3. So topic 4 is where we started electricity. So there's going to be 0 electricity on the test. So I'm saying that again. Now guess what I'm probably going to tell you on Tuesday is that the next Tuesday we're probably going to have a test on electricity. But for this test on Tuesday, it's just section 01, 02, 03. Does anybody have any? Are we going to start lab next week? I'm sure that we will be in lab no later than Friday of next week, at the very latest. We'll be in lab on Friday next week. I'm sorry? No, we don't have a field trip this Friday. I'm waiting for the air traffic control tower to get back to me. No, we're probably going to have to build different, larger, gnarlier rockets. The extra ones came in. So at break time I'll tell you, you can look up a photon probe. Okay, so now if you're in your house, let's think about you got a water pressure gauge hooked up to your house. Water pressure in house is usually somewhere between 40 and 60 psi. We'll say it's at 50 psi. You got a water pressure gauge hooked up in your house somewhere. It says 50 psi. If you turn everything off, And the toilets are filled up, so they're not running. Does the gauge still say 50 psi? Is the water still trying to get out? If you open up a valve, won't water come out? Okay, so there's pressure inside the pipes, yes? Okay. Can you have pressure but no water moving? Yes. So this is identical to a fully charged battery that's not hooked up to anything. It has pressure. The electrons want to get out of the negative side. They want to go to the positive side, but if there's no path for them to go, the amperage flowing, the current flowing is zero. That's why you don't what? That's why, yes and no. You're asking about why don't you store lead-acid batteries on the ground? Okay, so you asked that question, so that means the best time for the answer is right now. And yes, it is better if you take a lead-acid battery and you place it on the floor, and it's usually they talk about cement. The electrons want to go from the negative side of the battery to the positive side. But the resistance of the air of that 6 or 8 inches is really, really high. In fact, that resistance is so high, it's almost infinite. So electrons can't flow. But the plastic of the case and the cement are not quite infinite. So a very, 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 very few number of electrons will travel on the outside of the case, and the cement has even less resistance than the case. Then they'll go up the case to the positive side. Very, very slowly. So it would take weeks before you would notice. What's more important about lead-acid batteries, I'm not going to ask you this on the test. What's more important about lead-acid batteries is you need to charge them at least once every 30 days. Lead-acid batteries, whether it's in a car, an airplane, or a boat, like marine lead-acid batteries or the lead-acid batteries in golf carts, lead-acid batteries will last longer if you store them fully charged. And in fact, if you let them drain till they're completely dead and you charge them back up, they won't be as full as they used to be. There's a chemical process in the battery that some of it deteriorates and it ruins a little bit of the battery. If you take a car and you leave the lights on overnight, you come out the next morning, you try to turn the key, click, click, the starter doesn't even spin. Oh darn, and you realize, oh yeah, I left the lights on. You jump the car, you get another car up and you jump the battery, and so it starts, and that alternator in the car starts charging your battery. You drive it around for an hour or 2 or 3, a whole tank full, and you let the car stop. If you come back within 10 minutes, maybe even an hour or 2, you're not going to notice the difference. And in fact, if you've only drained the battery dead once, you shave, instead of that battery lasting for 5 years, maybe now it's going to last for 4. But let's say a month or 2 or 3 later, you let the battery go dead again. You jump it, it works. You drive around, you shut the car off, you go into the mall, you come back, you start the car up, it works. The battery seems to work. But now the battery's not going to last for 4 years. Now it's only going to last for 2. But if you do this that 3rd or 4th time, you've ruined enough on the inside of this lead-acid battery that if you charge it up at night and you've driven it around all day and the battery's completely charged, the next morning you get up, you turn the key, run. The battery's no good. So lead-acid batteries, you hopefully never drain them down to 0. They're not designed to be drained down to 0. That's really bad for them. And so that's what happens. Even if you set it on something that didn't have a little bit of current flow, you still need to charge it every 30 days. So this is really not the big issue. The big issue is if you have a lead-acid battery, you need to put a battery charger on it all day, 1 day a month. Or you can buy a battery charger that you plug it in and you hook it up and you leave it there, and it only charges it a little bit all the time. And that $20 battery charger is cheaper than a $100 battery. Like at my mom's house, she has a riding mower because we're out in the country and she's got a lot of grass and weeds. But in the winter, we don't drive it for 2 or 3, 4 months in a row. So I got a battery charger, and it's plugged in all the time. And it keeps the battery, and it's got a computer chip inside of it. So when the battery gets full, it stops. It waits for about an hour, and it checks it again. Oh, that battery's very, 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 very slightly discharged. And it comes on for 1 minute, and then it stops. And it just sits there for 4 months. But now I'll still have a good lead-acid battery. So that's batteries that are made, that most batteries in cars, almost all the batteries in cars, and almost all the batteries in little airplanes and little helicopters use lead plates and sulfuric acid. And that's the kind of batteries I'm talking about. Did I answer your question way more than you wanted? Yeah, way more than you wanted? Okay. All right. So if we were going to look at an electric circuit right here, so on the test, I could give you a really fun question. I'd draw the picture of a battery, and I'd say, label the negative side and the positive side. Mr. Sandoval, which side is the positive and which side is negative? The top or the bottom? Try again. The bottom, yeah, that's right. Very good. The side with the long lines is the positive side, and the side with the short line is the negative side. So here's our switch. Here's our light bulb. Now, right now, this switch is open. That means the light bulb is off. The resistance of this gap of air is so high, no electrons can jump across it. Not if we're talking 12.6 volts. Can anybody tell me where did I come up with 12.6 volts? I know it's been like 4 days, so go ahead, Jaron. A 12-volt system, but what kind of battery is this good for? NiCad battery, lithium-ion battery? Pretty much every car battery and the vast majority of airplane and helicopter batteries are lead-acid batteries that are 12-volt batteries, but they're not really 12, they're 12.6. If the battery's brand new and it's fully charged and it's 80 degrees Fahrenheit. If it's colder than 80 degrees Fahrenheit, this will be a little bit lower. It might be 12.5 or 12.4. If it's 100 degrees and it's brand new fully charged, it might read 12.8. All right, so if I hooked up a gauge, a meter, I'm going to have to figure out why this is doing it. If I hook up a voltmeter, and this switch is open, but I hooked the voltmeter up here to here, we got two choices. It's either going to read 12.6 volts or it's going to read 0. Any guesses? You got a 50-50 shot. I'd harass Josh, but I've harassed him enough this week. I have a 12.6. What do you think? The switch is open. I want to know this voltmeter hooked up right here. I'll give you a hint. I'll give you a hint. Look at that. What? Yeah, it's going to read 12.6. It's going to tell me the water pressure even if no water is moving. In this case, it's going to tell me the electrical pressure even though no electrons are moving. Now, if I wanted to measure amperage, I would have to open the circuit up and stick it in there to force the electrons to go through it. So now, just for fun, we'll say that this is open. The switch is open. How many electrons are going through this circuit? How many? 0. So how many amps is this thing going to say is going past it? None. 0. So if you want to measure current flow, you have to close the switch and let the electrons move. Because amps is a measurement of how many electrons are actually moving. So there's two ways to write Ohm's law, V over IR, or you can write, there's 17 different ways. V over IR, V over amps times resistance. You could write it volts over amps and ohms. You can do it a million different ways. So I recommend that you pick one and stick to it. I'm probably going to write it E over IR because that's the way I was taught to do it. So the nice thing about this circle like this is you can stick your thumb over any one of these three, and now you have the formula to find it. So if I want to find out what current flow is, that's amps. I just stick my finger over the I, and it's E divided by R. Watch out, Josh, this is a division problem. If I want to know what E is, I stick my thumb over E, and it's I times R. E equals I times R. And if I want to know what R is E over I. R is E over I. So if you'd rather do it volts, and amps and ohms, or volts and amps and resistance, that's okay. I don't care. I don't care how you do it. We're going to do a really easy problem here. Huh? The answer is 7? Here, we'll close the switch. So we'll say that this is 35 volts of DC, and this has 5 ohms of resistance. And the question is amps. And what was the answer, Josh? 7. Does anybody have any questions about how to do that? Josh knew what the answer was, intuitively, right? So if the question is amps, if you do volts, oh, what is that? Volts over amps times the resistance. If I want to know amps, amps is V over R. Amps is volts over resistance. And in this case, we have 35 volts, and the resistance is 5 ohms. Just so you know, Josh, if you tell me what the answer is before the test, I'm not going to write the question to fit your answer. Because that's too hard. I'd forget what the right answer was. No. I appreciate you saying please, but the answer is no. So did you have to use a calculator for that, Josh? All right, so let's pretend that, let's say that it's 24 volts. Does anybody know what's a common thing in the United States that runs off as a 24-volt system? Semi-truck batteries. Yeah, in the United States, 18-wheel tractors, 18-wheelers, those are machines that have 24-volt systems. 24-volt systems. Also in the United States, bigger airplanes and helicopters have 24-volt systems. Yes? What do jet aircraft have? They have 110 and 220 volts AC that like comes out of the sockets, except theirs is 400 hertz instead of 60 hertz. So it's 400 cycles, so you can't plug your airplane into household current. So here the question is, what is the resistance? So 24 volts will push 2 amps through this light bulb. So if I want to know resistance, the resistance is V over A. Volts over amps. I know this is really tough. 24 volts over 2 amps, 12 ohms of resistance. So the first lab, or the second lab we're going to do, is we're going to calculate this in an aircraft circuit, and then we're going to measure it. Not because you're going to calculate numbers a whole lot, hang on a second, but because I want you to practice using a volt ohm meter that measures volts and ohms and amps. Question? How does it get restricted to 12 volts? Well, in a diesel truck, they either have a 24-volt battery by putting in extra cells inside the battery, or they just hook up two 24-volt batteries, two 12-volt batteries. So it's not really restricted to 24 volts. It's pumped up to 24 volts. Am I answering your question? Yeah. If ohms? Okay, really, it started out the manufacturer built this light bulb with 12 ohms of resistance. The resistance of the wire is so close to zero, it's not worth worrying about. This wire right here is 0.002 ohms. So typically, unless we think something's wrong with the wire, we make an assumption that the wire has almost no resistance. So the only thing in this circuit that has resistance that we have to worry about is the light bulb. So it comes out of the manufacturer at 12 ohms. I was just trying to give you an example. We did one question on how to figure out resistance, another question right now how to figure out amps. So you're probably not going to be able to guess what's the next question. Say that again? No, that's you're the answer. I asked so somebody could figure out the next question. This time we've done amps, we've done resistance. Now we're looking for volts. Let's see. In Espanol, I would do this, and then I would tell me if I'm right here. That you put the if it'll let me, it won't let me. Eraser that, yeah. So it's not. It's me that won't let me do it. Is that correct in Espanol? All right, sweet. See, and people didn't think I knew any Spanish at all. Okay, I know extremely little. All right, so if we wanted to know what the volts are of the battery, and somebody told us that this had 10 amps going through the wire, and this light bulb had a resistance of 20 ohms, can we figure out how much voltage do we need to push 10 amps through a 20 ohm light bulb? Well, sure, we use this formula. We cover up the V, it's A times R. V equals A times R. In this case, amps is 10, and the resistance is 20. I know this is really tough. Get out your calculator. We'd need 200 volts to push 10 amps through a 20 ohm resistor. So the landing light, just for fun, the landing light in my airplane, let's just say when the alternator is running, it's 14 volts DC because the alternator puts out a little more volts than the battery. And I have a 10 amp circuit breaker, which means it's pumping about 7 amps through the wire. So the question is, what's the ohms? Two? I think you're right. So if I want to find out the resistance of this light bulb, that's R. I cover up the R. It's V over A. V over A equals R. In this case, it's 14 volts over 7 amps equals 2 ohms of resistance. So that's not a lot. Again, we're making an assumption that the wire has no resistance. Okay, this is Ohm's law. And if you're going to be an airplane mechanic, or you want to fix something electrical on your car, or you want to fiddle with batteries and a flashlight, understanding Ohm's law is really important. You could measure the flashlight light bulb resistance, and let's just say it's 1 ohm of resistance, and it's got two batteries, 1.5 and 1.5 volts, 3 volts. 3 volts, 1 ohm of resistance. How many amps is going through the light bulb if all the connections have 0 resistance? Yeah, so the light bulb has to handle 3 amps. See, that was tough. You divide it. Did you just divide in your head? Oh, he told you the answer? Okay. All right, that's enough Ohm's law. So I'll tell you what. If I put this on the test, and you have, can you do these problems? Okay. Is it okay if I give you that little round thing with V, A, and R on it? I'll probably screw up and forget and give you the E over IR, and then you'll wonder what the hell's going on. But all right. I want to talk about power now. Power is measured in watts. This is another reason why I like to use I over E, because watts equals volts times amps. And in fact, in alternating current, they usually, instead of calling it watts, they call it volt amps. And I'm not going to get into the reasons at the moment. But power in watts is the voltage going through the circuit, the voltage that's applied to the circuit, the voltage that's powering it, times the amps. So we talked yesterday about a 50-watt cell phone charger. Let's try a 20-watt cell phone charger. And let's say that's 20 watts leaving it. So what's cell phone chargers? What's the output voltage? Not what's coming in from the wall, but what's the output? You know, that USB. How many volts are USB outlets? Their voltage. Move the decimal. Yeah, that's right. They're usually about 5 volts. USBs are about 5 volts. So if it was 20 watts, could we figure out how many amps this thing will put out? Now, most cell phone chargers or iPad chargers, they're 1 amp or 2 amps or 3 amps. Has anybody ever seen one that's like 4 amps? Somebody somewhere's probably made one, but I think most iPads you need a 3 amp one. So if we plug the numbers in you could also do it like this, W equals A times V, but that's way too easy. So everybody, in the electrical world, everybody calls it volt amps. So watts is 20, and the volts is 5, and we're looking for amps. So this is where you got to get your calculator out. We want to get A by itself. We divide this side by 5 and divide this side by 5, and we get 4 equals amps. So if the output of this USB phone charger was 20 watts, and it only had one thing to plug it in, then that would mean you could get 4 amps out of it. But probably, if you looked at the side of this thing, if it said 20 watts, is that probably the amount of power going into it or the amount of power going out of it? They're trying to sell it to you as being very powerful. And this is the United States. They can deceive you as long as they don't lie too badly. Yeah, it's going to be the power going in. Let's just say, for instance, that this was 80% efficient. It only puts out 16 watts output. Now we could stick the numbers in here. We'd have 16 equals 5 times A, divide by 5, and we get what, 3.2 equals amps? Something like that. Did I lose anybody there? I'm not going to ask you any percent power. Huh? Well, well, an amp is 6.28 times 10 to the 8 to the 18th number of electrons per second. It's a certain number. An amp is a certain number of electrons going past a point in a second. So if my cell phone, like if I take my cell phone and put it into a really cheap charger, and the phone will say, you'll charge faster if you use the charger that we sold you, you hose bag. Why don't you buy another charger from stinking Twit? Your cell phone tells you. But that's the way my cell phone talks to me. There's this app you can download, and it changes the messages. You can actually type in your own message. I know, and you believe that there is such an app. I made that up. So there is an app, but I didn't make that app. But if there was, I would spend money. I would spend $50 for that app. If I could change the messages to what I wanted, that's what I need to do. That's my $1 million idea. I need to hire an app developer. No, all I want to do is become a millionaire off of my cell phone app that you can modify your messages. Because you can make it say neener, neener, neener at you. Your battery's almost dead. Neener, neener, neener. That's what I would do. And then you could charge people for an extra $20. You could sell them the version with the naughty words. They would pay extra. Wouldn't some people pay extra money for the naughty words? I hadn't even thought about the voices. There's a whole other add-on. That's another $20. Now you could have people cursing at your phone, cursing at you, instead of just humans. Not that humans would curse at you, Josh. That's just me. I'm talking about my life. So where was I? Oh yeah, what I do think is important that you understand that power devices, how much energy you put into them, less energy comes out because some of that energy gets used up in the device because it gets hot. Just from heat. Well, the quality of the charger, you could base it on, does it put out 1 amp, 2 amp, 3 amps? Battery, so 1 amp, I plug it in, it might take 5 hours. If I buy one that puts out 3 amps, it may charge my phone in an hour and a half. So they're both quality in that they don't break, but one's better because it puts out more amperage. So it'll charge your battery faster. And yes, the charger that came with my phone, it'll charge my phone in less from almost dead in under 2 hours. But I don't need to because I plug it in at night. The more amps that it have, can it damage your phone? No, cell phones are designed not to let too many amps in. It measures it and then increases the resistance to reduce how many amps come in. So I can take my cell phone and plug it in, and let's say it's designed for 3 amps, I can plug it into a 10 charger. As long as the charger is at 5 volts, my phone won't overcharge. So that's the other thing that's really good about electrical systems in your house, electrical systems in cars, electrical systems in airplanes, is they're designed to have a reasonably constant voltage. Now, I alluded to earlier that, the alternator in my airplane puts out 14 volts. Well, that's because it's got to charge the battery, right? So it's got to have a higher voltage so it can push electrons back into the negative side of the battery. So if the battery is 12.6, and this is the same for cars, then the alternator put out 13.5 or 14 volts. So that when it comes on, it doesn't just supply power to everything on the aircraft or the car, it actually charges the battery. If that alternator was only putting out 12.2 volts, then it would only charge the battery up to 12.2 and it would stop, and the battery would never be completely charged. So if you're trying to, that's one of the things you can do if you're trying to figure out what's wrong with your car because it's not charging the battery, you get it started and you put a voltmeter on it. Even you can put it right across the battery, and it'll tell you what voltage is being supplied to the battery coming off the alternator, and it ought to be 13.5 to 14. If it says 12, then maybe the alternator's bad. It could be the wires, it could be the connections. And that's another thing with the problem with lead-acid batteries. Sulfuric acid is corrosive, so crud builds up where the battery cables come in. So if those connections are bad, it might not charge the battery. And in fact, if those connections are bad, you could have a good battery, and the connections are bad, the electrons can't go through the corrosion, through the rust, and get to the starter motor. So you may start it, and the car goes, rah, rah, rah. And it's not because the battery is dead, it's because the electrical connection at the battery is bad. Oops. And I don't care about that. Whoops. I care about that one. Man, it's a quarter after. We're going to finish this slide and then we're going to stop. So I'm not going to ask you this question. And if you want to do PAV, that's okay. If you'd rather do W times VA, that's fine with me. So here's the question. If I give you this formula on the test, can you do the calculations just like Ohm's law? Is it okay if I give you numbers that work out that there's no decimals or fractions? Is that okay? And that way even Josh can do the math without his calculator? Huh? You can't have Frederick during the test. Huh? You can't use a calculator during the test because the only calculator anybody has is their cell phone, and you can look up the answers to the test on your cell phone. So you're gonna have, it's like pilot math, man. Pilot math is the kind that you do without calculators. I'm not going to ask you this on the test, but I find it very interesting, so I can't help but discover it or talk about it. If you have an electric motor, and you say that motor puts out 746 watts of power, then the output shaft is 1 horsepower. Go ahead, Jonathan.
So, do you know how much Tesla costs?
No, I don't. I'm not that familiar with Tesla automobiles, other than they have really long range, they're very expensive, and you can update the software on the car via the internet. And they look nice. And Mr. Musk is going to launch one on the Falcon Heavy, the first launch of the Falcon Heavy. He's taking his personal Tesla cherry red car, his very own car, and he's going to launch it into an orbit. It's going to go right past Mars, and it's going to enter an orbit around the sun. And for as long as the batteries will last, it's going to play Space Oddity by David Bowie. It's not going to be transmitted through sound. It's going to be transmitted via radio waves. And radio waves can be heard or picked up. So the Falcon Heavy, it's supposed they might launch it this month or next. No, it's never going to come back. They say the word billion, that it's going to orbit the sun for 1 billion years. But if the batteries go dead, it won't transmit the song. I think they ought to put some solar panels on it, and then it could transmit for forever. That would just be. So what I'm going to do is I'm going to find out what frequency it is, and I'm going to find there's got to be a way that you can buy a receiver, radio receiver, and listen to it. That when we get close, like 100 million miles away or something. So I got a question for anybody except Josh. Let's say that this 746 watts is the input going in electrical power. So now the question is, how much is the shaft horsepower? We're putting 1 watt, we're putting exactly 1 horsepower into the motor. My question is, how much horsepower do you get out of that shaft? If we put 1 horsepower of electricity into it, how much comes out? Yeah. How efficient is it? Guess. You've been in class for days now. 80%. So let's say it's 80% efficient. So how much horsepower? I know it's going to be really hard. 7 times 8. What's that, 56? It's going to be like 580 watts. And 580 over. Oh, yeah. Oh, wait. If it's 80% efficient, then that means it's going to put out 0.8 horsepower. I don't have to do any of this. What makes you think it's only going to be 80% efficient, Mr. Flores? Nothing I've seen is 100% efficient. Yeah. In particular, electrical devices. What's going to happen to the temperature of this electric motor when we're pushing electrons through it? It's going to get hotter. It's going to increase its temperature. I know you don't know it because I haven't told you unless you might already know it. What's the number one basic component inside an electric motor? It's made out of a whole bunch of copper wires because it's an electromagnet. So that's all. And the motor is converting electrical energy into rotating energy. But wait, 10 or 20% of it isn't going to get converted into rotating energy. Ride a starter motor on a car by cranking the motor so much that the motor got so hot that the insulation on the wires melted. It's really hard on a car to do that. It's really hard on a car. There's some airplane engines where it's not very hard. Let's take a break until 31 after. 31 after.